Hello friends, this video on chemical reactions and equations part 9 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 8. Now we'll see the analogy of displacement reaction, the scenario which we have in real life which is almost similar to displacement chemical reaction in real life. So there we have one compound AB. Another compound C comes and it displaces this B and the B comes out. That's how it is. There's a compound AB, they're happy together. One guy comes C and C displaces this guy because A is attracted more towards B, or something happens, right? You apply some heat to something, so this becomes AC plus B. For example, in the real life, let this guy be A who is dancing happily with his partner and the partner is B. Right? So they're happily dancing. Now the instructor sees one more girl come and she's also a good dancer. Now the instructor sings, but nothing happens, right? So they are happily dancing, one more person C has come, the person C has come, but nothing happens. Or maybe the moment the person has comes, this thing got displayed. Or the external factor is required. The external factor is supposed to be instructor. Instructor says that, dude, this lady is wearing a red dress and you are wearing a blue. It won't look good in the stage. So why don't you swap? Why don't you swap? So then what happens? This lady swaps with this girl and this girl comes out here. So if you see now, earlier A and B were dancing together. There's one new girl who came in C. The instructor told that the dress looks better, the blue and blue. So why don't we dance together? So now if you see, this guy is A and C. Now A and C are dancing and the B lady who was here, now B lady is out. Right? It may be that A likes to dance with C. It may happen that you don't even need instructor here. The moment C comes, B tells no, I don't want, A tells to B, I don't want to dance with you because you're wearing a red dress, I want to dance with C. Maybe this guy himself tells because maybe that this guy is inclined toward this lady, or maybe this guy is not inclined that much, but the instructor forced him to do it. So maybe this reaction happens on its own, or maybe happen on some external force, for example, heat or temperature, or temperature or pressure or something, or some catalyst also, right? So some catalyst also may be required for this. So, but end of the day, you forget this part, you exclude this part to make it life simple. But end of the day, what's happening is A and B were dancing, C came, and now A and C are dancing and the B is gone, right? So this person C took the place of B and the B is out now. Correct? This may happen in the real life scenario when you're practicing dance in the schools and the teacher tells that no, this pair doesn't look good, let's change the pair, right? So that's one example of a displacement chemical reaction in our daily life. So let's see the chemistry definition of this displacement chemical reaction. You have this product AB. When C comes, C displaces this guy B, so it becomes AC and the B is out. So it says that one element or ions moves out of one compound and into another. One example is active acid plus active metals. You get this kind of reaction. This is one example of that. So we'll take more examples. So you have hydrochloric acid and magnesium if you add. So you have hydrochloric acid and magnesium. What you get is MgCl2 and H2. So what you have seen this Mg, it came here and it paired with Cl and hydrogen is kicked out. Correct? Sulfuric acid plus iron is equal to iron sulfur plus hydrogen. So here if you see, iron came here, it kicked out hydrogen, and hydrogen is an independent identity now. Correct? Fe kicked out hydrogen and it become FeSO4. Here you see nitric acid plus magnesium, nitrogen, hydrogen. So we have nitric acid HNO3 plus magnesium, it gives magnesium, nitrogen, hydrogen. So if you see the magnesium came here, kicked out hydrogen, and the hydrogen is out, right? And magnesium and nitrate become magnesium nitrate. Zinc you add with hydrochloric acid, this becomes zinc, chloride and hydrogen. Zinc and hydrochloric acid, if you see the zinc guy overtake this guy HCl, hydrogen is kicked out and this guy is out. So in this, if you see, this happened because zinc wants to gel up with chlorine more, right, than hydrogen. So zinc has a more affinity to gel up with chlorine than hydrogen, and then it pairs, creates a bond with chlorine, and the hydrogen is kicked out. So we'll understand all these things I think in the class 11 when we discuss the atoms, the shape of atoms, and how they have neutrons, protons, and electrons, and what makes it stable, and why this reaction happens, right? So all these things we'll study in class 11, the reason behind this reaction, why it's happening. You must be wondering, right? But when you add zinc and hydrochloric acid, why it becomes reactant? This is the answer to this, but now it will be too difficult for you guys to understand because in class 10th now. Once you move to class 11, we'll understand why this thing happens, because zinc has more affinity to attach with chlorine than hydrogen. So that's the reason why it happens, right? So we'll learn all the things in class 11, but just for now you can understand that this is a kind of displacement chemical reaction where one element displaces another. So here also lead plus sulfuric acid becomes lead plus sulfate plus hydrogen. This guy lead kicked out hydrogen, and hydrogen is out now, and this becomes lead sulfate. So this is one example of displacement chemical reaction, right? So for this we'll do an activity. So we'll take 2 iron nail and 2 test tubes marked A and B, and in each test tube take 10 ml of copper sulfate solution. So we have 2 iron, 2 test tubes, right, and this is going to be A and B, and both has copper sulfate solution. Immerse 1 nail in copper sulfate solution for in test tube B for 20 minutes. So in test tube B will immerse this nail. In test tube A won't immerse, and will this keep for this 20 minutes. And after 20 minutes, it would take out this nail from this test tube B, right? Please note, test tube A we are not even touching, that's just for show. We'll compare this later. Test tube B is something which we are doing stuffs now. So test tube B we have put this for 20 minutes. It's all copper sulfate solution, right? Now after 20 minutes take out this guy nail. So we'll see that after 20 minutes the color change. The color of copper sulfate also change, and the color of nail also change. And we'll take out this guy after 20 minutes. Now compare the intensity of the blue color of copper sulfate solution. If you see, this guy is dark now and this guy is light. Both are copper sulfate, but this guy become lighter. And also if you see if you compare the nails also, they are different. There's more blackish now, right? So both has changed. The nail color has changed and the copper sulfate solution has changed. What has happened? What has happened is you had this iron, that is the nail. In this you dipped with copper. You dipped this guy in copper sulfate solution. What you got is FeSO4. Now this guy is FeSO4, right? And this guy is a little copperish. This is not black actually. This guy should be a little copperish color. So this guy is a copper. This guy is a copper. This guy got a layer of copper here, right? So this guy is a copperish color, and this should not be black. There's some issues with animation. This guy should be a little copperish color, and this guy becomes a lighter color because FeSO4 is lighter and CuSO4 is darker. So that's how it happened. This CuSO4 become FeSO4, and this iron got a layer of copper. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.